Hi, my name is Alexander. Welcome back to my channel. In this and in the next videos, we will create projects with Angular routing. The Angular router enables developers to build single-page applications with multiple views and allows navigation between these views. We can also configure routes to guard against unexpected or unauthorized behavior. Starting with Angular 14, you can create the whole application without making any custom Angular modules, which is possible by using standalone components, which provides simplified way to create an Angular application. But for the projects created with Angular versions up to 13, to enable routing functionality, we have to use Angular modules. In this video, we will implement routing for the not standalone projects created with Angular versions up to 13. In the next video, we will implement routing for the standalone project created with Angular version 14 and newer. We will create not standalone project with the latest Angular version 18. Because starting from Angular version 17, standalone components became the default in our applications. To create no standalone project, we have to use additional option, no standalone. Go to Projects directory. Check Angular version. Angular version is 17. Node version is 20.9.0. Let's upgrade Angular version to 18. Angular version 18 supports Node.js version 18.19.0 and newer. We have Node version 20. Typescript version should be 5.4 or newer. We have 5.4.5. So we can upgrade Angular version to 18 using this command. Check Angular version. We can see that Angular version has been upgraded to the version 18. Open Visual Studio and try to compile our project. Open Terminal. npm start. Project compiled successfully. Check in a browser. Everything okay. If you want to generate component which is not standalone, you can use this command with the parameter standalone false. Or if you want default behavior like to be standalone for each generate command, you need to implement change in angular.json. We created non-standalone project, that is why in angular.json file we have the default behavior. Standalone false for Angular component, Angular directive, and for Angular pipe. Let's create two components. Component first, component second. Now, when the first component is loaded in a browser, we will see the message component first works. When the second component is loaded in a browser, we will see the message component second works. Create CSS classes. Let's create a table in app.component.html and add components selectors in the table's cells. Compile and start application. Both components are loaded when application starts. Let's use Angular router to load components. Open App Routing module. Angular router can be installed from the Angular router package. It implements the Angular router service, which enables navigation between views as users perform application tasks. There should be only one router service for the single Angular application. For root, we'll initialize that service and register it to dependency injection. Router module for root implements router initialization. It initializes the router service and sets up the router environment for the entire application. This includes creating the router singleton instance and providing it to the application-wide dependency injection tree. Road configuration. For road method allows to define the initial road configuration for the application. This includes specifying the roads, their corresponding components, and any additional road-related settings such as road guards or resolvers. To use the router service in the application, we have to import router module. We have to define the route object that maps URL path to the component, and the router outlet directive that is used to place a routed view in a template. We didn't use Angular router to load components, therefore app routing module doesn't contain any routes for the components. Routes array is empty. Route tells the router which view to display when the user clicks a link to URL. Let's comment our component selectors in app.component.html. Instead, we will create routes in app routing module for loading our components. The simplest route consists of the property path. It is a string that specifies the URL path for the route. And property component. It is a string that specifies what component your application should display for that path. In app routing module, import our components and create routes for the components in app routing module. In app.component.html, add links to the components. Sometimes hyperlinks are enclosed with nav tag like this. But it is not necessary. The nav tag should only be used for significant navigation links that help users move through the site or a large section of the page. The router outlet is a directive that's available from the router library, where the router inserts the component that gets matched based on the current browser's URL. You can add multiple outlets in your Angular application, which enables you to implement advanced routing scenarios. We will do it later in this video. Router outlet is a placeholder for the component that we will load by clicking on the route link. We put the router outlet in the next row of our table. Compile and start application. Click first component. The first component is loaded in the router outlet placeholder. Click second component. The second component is loaded in the router outlet placeholder, replacing the first component. If we need that both components can be loaded on the page, we have to create auxiliary route. To create an auxiliary route, we will need a named router outlet where the component associated with an auxiliary route will be displayed. Let's add additional router outlet with the name second. Add the name of this outlet to outlet property of the router for the second component. The syntax of the router link for the second component should be corrected as well. Compile and restart application. First component, second component. Now, by clicking the router links, we can load both components. Programmatic router navigation. Another way of doing router navigation is to use the router programmatic API to do so. For that, we just have to inject the router into our component and make use of either the navigate or navigate by URL navigation methods. Let's do it for the first component. Import router from Angular router package. Inject the router into app component and create the method first component to navigate to the first component. Comment router link for the first component and add the button. The first component will be loaded by button click. Compile and start application. Click first component is loaded. Click second component is loaded. Road guards. A road guard is a feature of the Angular router that allows developer to run some logic when a route is requested. And based on that logic, it allows or denies the user access to the route. It's commonly used to check if the user is logged in and has the authorization before he can access a page. You can add the route guard by implementing the canActivate interface available from the Angular router package and extends the canActivate method, which holds the logic to allow or deny access to the route. Let's create class guard that implements canActivate interface from Angular router package. The getDay method of date instance returns the day of the week for this date according to local time, where 0 represents Sunday. CanActivate method returns false for Sunday and true for all other days of week. Add canActivate attribute to the route for the first component. Compile application. Today's day is not Sunday. Try to load first component. First component is successfully loaded. Let's change the rules so that the first component can be loaded only on Sunday. Click first component. The guard method canActivate works. We cannot load first component today. Nesting roles. Angular router allows you to have roles nested inside already defined roles. With child roles, we can have a component-like structure defined for the roles in your application. It is critical as there are views that the user should not be able to access unless they are in a particular view. This way, the structure becomes tree-like, just like the structure of the component. We will create the child roles and display the components we link to them. Create child components. Second child 1, second child 2. Add these components as a child components to the second component. Add a roles for these child components in app routing module. Import child components. Add child roles. In the second component.html, we have to add router links to a child components. Let's create a table for this. We have to indicate only path child 1 for the component second child 1 component, and the path child 2 for the component second child 2 component. Route matching algorithm will append each this path to the path of the parent component to get the whole URL path for the child components. Add router outlet directive. It is a place where child components will be loaded. The application will load second component. Second component contains the links to a child components. By clicking the links, we can load child components. Click first component is loaded. Click second component is loaded. Click child 1 component is loaded. Click child 2 component is loaded. Route matching strategies. The Angular router provides different route matching strategies, prefix and full. The default strategy is prefix. Path match full means that the whole URL path needs to match. Path match prefix means the first route where the path matches the start of the URL is chosen. For example, for our child components, it is second component. But then the route matching algorithm is continuing searching for matching child routes, where the rest of URL matched. It is child 1 or child 2. Lazy loading. To load components, we will use lazy loading. Therefore, we will create module and routing module for every component. Let's implement lazy loading for the first component. Command generating first routing module and first module. Engine generate module second routing. Command generated second routing module and second module. By default, ng modules are eagerly loaded. This means that as soon as the application loads, so do all the ng modules, whether they are immediately necessary or not. For large applications with lots of roles, lazy loading, a design pattern that loads ng modules as needed. Lazy loading helps keep initial bundle size smaller, which in turn helps decrease load times. To lazy loading Angular modules, we use load children instead of component. In our application road module roles, configuration as follows. Remove import first component and add path to the first component in the first routing module. In the lazy loading, first module imports first routing module, where we have a path to the lazy loaded component, first component. Compile application and test. Click first component. First component now is loaded as lazy loaded component. When we want lazy load a parent component, all its child components are loaded together. Configure lazy loading and routing for the second component, like we did it for the first component. Remove second component and its child components from app routing module. Configure lazy loading for the second component. In a second routing module, import second component and its child components. Add path for the second component and its child components. Click first component, click second component. Now the first and the second components are lazy loaded. Let's implement lazy loading for the second child1 component, which is the child component of the second component. Add modules to the second child1 component. In the routing module of the second component, implement lazy loading of the second child1 component and remove import of the second child1 component. In the second child1 routing module, indicate path for the second child1 component. Now, the second child component is lazy loaded. Its first child component, second child1 component, is lazy loaded too. But the second child component, second child2 component, is eagerly loaded. Let's compile application and test. Both child components are loaded successfully. One last thing that I have to mention. In the road, the path can take a wildcard string, double asterisk. The router will select this road if requested URL doesn't match any paths for the defined roads. This can be used for displaying a not found view or redirecting to a specific view if no match is found. One of the key things to know about routing configuration is that the order matters a lot. When a router receives an URL, it will start going through the configuration in order, starting with the first element of the configuration array. If it finds a match to the complete URL, it stops and instantiates the corresponding component. So in this case, if we will put the fallback configuration in the beginning of the array, every URL will match to the double asterisk wildcard, and this break routing. That's why we should put the fallback route configuration as the last entry in the array. In the video description, you may find a reference to a source code in a GitHub. In the next video, we will implement routing for the standalone projects created with Angular versions 14 and newer. Thank you for watching. Please subscribe to my channel and have a good day.